Hey, hi, how about now? Are you able to hear me now? Friends? You know, hey, wonderful. Yeah, so let me again take the poll. Let me just cross check with others. Um, yeah, just a minute. Just let me take the poll. Yeah, please let me know if you're able to hear me. Okay. Okay, wonderful. So you're able to hear me now. Perfect. All right. Yeah. Thanks for the confirmation. Okay. There are still few people who are not able to hear me. Okay, that's a big number. Hmm. Okay, whoever is not able to hear me, I request you people to just refresh and rejoin the session. It should resolve the problem. All right, so let's start the session. Before I begin, I would want to take a poll. Okay, let me share the screen first. So looking at this particular mind map, and let me ask you a question here. How many stages are there in CRISP DM? Say 4, 5, let's say 6, and 8. Please answer this question. Yesterday we were discussing about CRISP DM. Oh, wonderful. Okay, somebody saying 5. 4, okay. Hmm. Okay, 25, 18. We are not talking about stages of analytics, friends. We are talking about CRISP DM. That's a hint that I'm giving. Yeah, I hope everybody has provided their feedback, their answer. So answer to the question is 6 steps. CRISP DM here you can see on the screen is basically having 6 stages. If you talk about analytics, stages of analytics, that is 4 stages. Most of them, they're saying that they're not able to hear. Let me check. Are you able to hear me now, friends? Are you able to hear me now? Can you confirm, please, now? Okay, okay. Okay, now you're able to hear me. And how about the screen? Friends, hope you are able to see my screen as well now. Please confirm. Okay, wonderful. All right. Okay, guys. All right, so let's resume. Yeah, let's resume. I'll repeat the steps. I'll repeat the things that we discussed. Okay, we were talking about the business case that we were discussing yesterday. The objective that we had to solve was to minimize the fraud, right? And we also had the constraint in place. The constraint was to make sure we minimize the cost to the company and we maximize the comfort to the customer, right? So in order to do this solution, implement this solution, we need to look into the data. So we collect the data. And if you look at this, the data is generated and the data is getting stored into the database. Generally, banks have right RDBMS systems, Finacle, and all those things will be there. So the data is lying in the database. We are pulling that data. So this becomes secondary data. Now, once we get the data, we need to try and process it. You'll not be able to consume all the data. That is not required. We need only the transaction data, and that too, it has to be mapped to the customer. Now, let's imagine you are basically doing the transactions, right? You are purchasing, let's say, early morning, you're going to office. While on the way, you stopped at the fuel station and filled up your vehicle with the fuel. You used your credit card. So one transaction. Second transaction, probably you on the way you had some breakfast. You might have a breakfast. So this is another right transaction that we are recording. Maybe in the office you have given lunch to your colleagues, so that is another transaction. In the evening, while going back, probably you have purchased some kind of chocolates or something for your kids or your wife. So this is right another transaction. Like this, we have multiple transactions that we are recording. Right? Now, one fine day, these transactions are recorded in the database. One fine day, your card was used to purchase, let's say, 1 lakh rupee or probably 2 lakh rupee jewelry, gold. Your marriage anniversary and you decided to purchase gold. Now, this gold purchase is not a regular transaction for you. You don't do it regularly, right? So it's a one-off transaction that you may make. I'm not talking about a fraud case here. I'm talking about a genuine case. But the algorithm that we are going to develop is identifying the purchasing behavior, the pattern. So it looks into these transactions, daily transactions, and it marks a pattern for you who's unique. I mean, you are a unique customer, you have your own unique pattern. So it is marking that. Now, when your card was used for purchasing of a 2 lakhs gold transaction, this becomes an anomaly, exceptional case, right? Anomaly. So this exceptional case should trigger an outbound call. So it should alert the executive in the call center, and that trigger, right, or that alert should give a call to your customer. Until then, you don't disturb your customers. You call the customers only when there is a weird transaction happening on the card. Now that could be based on the amount, it could be based on various factors. For example, your card is stolen. You are in, let's say, someplace XYZ. Majority of you are connecting from Andhra, as I'm assuming. So let's say you are in Guntur. Okay, you are in that location. The transaction happened exactly at 2:20 p.m. Okay, there is one transaction that happened at 2:20 p.m. Probably 5,000 rupees transaction happened on your credit card. This is a genuine transaction. You purchased something. Okay. Now, when you were doing this transaction, somebody might have stolen your identity, the ID card, right? Identity. So they just clone it and do all those things, right? Now, let's say this card was used, let's say in Hyderabad at 2:30 p.m. Okay. And there was an amount of 10,000. Now, 10,000 is not an exceptional case, right? 10,000 is something which is regular, quite regular. You might be using your credit card regularly for making this purchase. But can you identify a fraud in this case? How can you identify if you can do that? That's the question. That's the idea that you have to bring in. So we do feature engineering as part of this particular pre-processing, data pre-processing step. I'm talking about feature engineering first. So if you look at the location, transaction 1 location, Guntur. The time is 2:20. The second transaction location is Hyderabad. The time is 2:30 p.m. Now, simple logic. Can anyone travel from Hyderabad to Guntur or Guntur to Hyderabad in 10 minutes? Yeah. Not possible, right? Humanly, it's not possible. So this should again trigger an alert. So here we are calculating the velocity. So we will measure the distance. That would give you distance. We would also measure the time and velocity, distance by time, right? So you will give some right humanly possible calculations as threshold values, and anything beyond the threshold will trigger that the transaction is a fraudulent transaction. Again, feature engineering will help us identify the fraudulent transaction. So you need to write that logic in your data. Now, once you collect the data, along with feature engineering, of course, you have to do a lot of these things. Now comes pre-processing. Now let's say you have customer name, gender, age, customer details, right? Location, etc., etc., etc. Customer details are there. For example, the customer's gender is not filled here. It's not there. Missed. So if data is missed there, then we'll call it as NA, not available. Mind you, it's not 0, it is NA, no value at all, right? So in this case, for these kind of cases, we will have to lose the entire row. That entire record is lost. Because ultimately, we have to define mathematical equations. We will have to come up with mathematical equations which would help us define the relationship between these variables. But if you have no value at all to substitute in the mathematical equation, how can you solve that equation? So if I say ax plus by equal to c, let's say this is x, let's call this as x, this as y. So I'm saying x here is not there. If it is not there, how can you solve that equation? It wouldn't be possible, right? It wouldn't be possible at all. So the entire record is ignored when we are doing machine learning algorithms. Right? So that's the drawback that we have with the mathematical equations. If you have NA in the data, it could be data entry issue, right? The person who is entering the details probably might have missed those details. So in such cases, you get these problems. Now, when you look into the pre-processing steps, right? We broadly classify that into data cleansing, exploratory data analysis, feature engineering. I've given you an example of feature engineering. You define new features from the existing features so that you get more information or better information for your data or business scenarios. Then data cleansing, data preparation, data munging, and data wrangling. Here, if you see, there are different steps that you have to perform. Depending on what data you are collecting, or what data is provided to you, or what kind of business problems you have to solve. So based on these two aspects, you will have, right, this various steps that needs to be performed. Yeah. Okay. Now, the first thing is outliers. I'll explain about outliers in a minute now. Let me talk about missing values. We're just talking about missing values, right? So my data is 1, 2, 3, let's say NA and 5. This is my data. Now, if I have missing value, what can I do? I cannot substitute, I cannot use this in the mathematical equation. So I need to do something called as imputation. The process is called as imputation. You're imputing a missing value. Now, the most popular imputation technique is called as mean imputation. Though you have a lot of techniques that can be applied, this is a small subset of what we can try and do. Mean is the most popular one. Mean imputation basically says, calculate the average of the existing data and substitute that average into the missing field. Simple. So what is the average on this data? So I will calculate average here, 1 plus 2 plus 3 plus 5 by 4. NA, right? I will not even consider that. So I have 3, 3, 6, 6 plus 5, 11, 11 by 4. So it's 2.75. The average is 2.75. So I'm going to add that 2.75 in the missing space. Mean substitution. Now you might say that, hey, how can you just add mean there? You're giving some other data altogether, right? No, I'm not added any data here. We are logically substituting some value which does not give any additional data. We are not adding any additional data. Remember that. Count the average here. Do the average here. You'll automatically know. 1 plus 2 plus 3 plus 5 plus 2.75 by 4 plus 1. So you're basically here you have divided this value into 4 parts. That was each part was 2.75. Now you are adding that, but the denominator also you're adding 1. So the value calculation will give you 2.75 only. It will be the same value. So in a way, you can see that I am not adding any additional data, right? This is called as mean imputation. There are various other options: median, mode, KNN, regression, hot deck, deletion based, substitution based. A lot of things are there. Then we might have to transform the data from one scale to another scale. Magnitude have to be altered. Discretization might be done. Say, for example, in the bank, you're asking the customer's age. The customer's age could be anything. So we are grouping that age into, let's say, 3 groups. You're saying young age. Probably you're defining it as less than or equal to 25. You're saying middle age. From, let's say, if I put 20, less than 25 to, let's say, 45. And old age, you're saying anything greater than 45 is old age. Right? So I've taken 45 wantedly because I want to be in this. So I'm still in middle age. Okay. Right. People who are all greater than 45 years, sorry, but you fall into old age if I do this kind of a categorization. So this is called as discretization or binning or grouping. It depends on what kind of problem you're doing. You might have to do that. You might have to group the data. Then we have normalization or standardization. This is to again alter the scale so that all the values that we have in the data set belong to the same level. Then we have dummy variable creation. Dummy variable creation basically is converting a non-numeric data to numeric format. So you might say, look into the same fraud case. The data set is talking about various aspects like name, age, location, right? Gender. Now gender, for example, I'll take this small example, can either be male or female, right? Now this is a non-numeric data, right? It is a non-numeric data. Now I'm going to apply this non-numeric data. I'm going to apply the dummy variable to convert this into numeric format. I'll simply mark male as 1, female as 0, or vice versa. You can put 0 here, 1 here. So your column here will get replaced with these values. You'll get numeric values, right? So that's your gender. This process is called as dummy variable creation. We also call it as one-hot encoding. We also call it as one-hot encoding. You just transform the values into numeric values. Then we have typecasting. Typecasting basically is you're converting, let's say, a float data to integer or to a string. Data types, these data structures I would rather call. These data structures are getting changed. That's called as typecasting. Then we have a handling duplicate scenario. If you have a lot of duplicates that are getting added into the data, you don't want that duplicates to be there. So you are going to filter out those duplicates. Then string manipulations. This is when you have textual data. You might want to do some kind of manipulations on text data. And finally, you also have something called as zero variance or non-zero variance. Zero or non-zero variance basically means you have a variable, right? You're talking about type of transaction. You're saying online transaction, online transaction, online transaction, online transaction. So credit card transactions I'm talking about. If you have 1,000 transactions and all the transactions are online, then do you require this column in the first place? There's no variation at all, right? You know that it is online. So you are not being able to identify any special thing from the data. It's already clearly given. It is online. But if you have a varied data here, if it says online, then physical card copy, right? Then you might say Paytm or wallet. What do you call this? Mobile wallets, right? Wallets, mobile wallets, or any other different types of transactions you might have. So all these things have to be recorded here in the data. And if you look into these variances, if you see the different types of transactions, then you will get, right, more information, or probably you can try and identify the pattern. For online, this is the pattern. For physical transactions, this is the pattern. For wallet transactions, these are the transactions. You will be able to manipulate the data and try and understand the pattern in those different categories. But here, it is online. There is nothing special that you can identify. Right. All right. So this is about your data cleansing. And it depends on your requirements on how you get the data, or how you basically, right, apply what techniques, how you're defining your data, what is your outcome that you're trying to find out, whether there is some data which needs to be manipulated or not. So based on that, you're going to cleanse, or you say prepare your data. Now, once this is done, you have pre-processed data. On that pre-processed data, you want to extract much more information. You want to gain more information to understand the business problem and the solution in a better way. So as part of that, you will be doing something called as EDA, exploratory data analysis. We in short, we call this as EDA, exploratory data analysis. And this is also descriptive analytics, right? So remember the first stage? We have descriptive statistics or descriptive calculations, then diagnostic, then predictive, and then prescriptive. So we are looking at exploratory data analysis as descriptive analytics. And here, when you are trying to dig into the data, we take one variable at a time. You might have, right, in that bank transactional case, this is your data set, you might have 30 to 50 variables, bank related, personal details, the transactional details, the vendor's details, right, etc., etc. You might have a huge number of variables. Now, out of that, when you prepared, you cleanse the data, probably you have taken 30 different variables for your analysis. Now, on these 30 variables, we will have to perform EDA, try to dig into the data better. But I will not take all the 30. I will take them, of course, but take them one variable at a time. One variable at a time. This is called as univariate analysis. So we are trying to do that now. So if I give you a data, let's say the transactions. Let's talk about amount. transaction amount as one of the columns in your data set. I have 1,000 transactions. Assume this is the data set. And one column is the transaction time, transaction amount. Now, by looking at this transaction amount, 1,000 different records, what would be your first question on this? If I give you this kind of a data, what would be your first question? Yep. The first question would be, hey, can you tell me what is the overall, what is the average amount for this particular customer? We're talking about one customer transaction, right? We're trying to identify pattern in one customer. And that customer has 1,000 transactions. So we have taken that data, we are analyzing the transactional behavior. So if I look into this transaction, then I will say, hey, what is the average amount that this customer is generally purchasing with? On his credit card, what is the average amount? So this average is basically representing a characteristic value of that particular variable, right? Isn't it? It resembles or it projects an image for the entire data. For all 1,000 transactions, average is going to be a representative value. And this average is, of course, also called as mean, right? This average or mean is called as measures of central tendency. Measures of central tendency, which basically tries to capture the essence or the centrality of the data, mass of the data. It is also known as the first moment business decision. So what exactly this means, right? Let me talk in terms of something which is probably more relevant to you people. So I'm taking an Excel sheet here. Okay, let's say we have a class of students, class A. And in this particular transaction, or in this particular data set, let's say we are looking into the marks secured by the students in one particular exam, right? So somebody is getting 80, somebody is getting 76, somebody is getting 90, somebody is getting 85, somebody is getting 79, so on and so forth. But one student has got 10 marks. One student has got just 10 marks. You have a lot of details like this, okay? Now, if your management is looking at this data, okay, say your management or your dean is asking on, hey, what is the performance of this class in this particular exam? What is the performance? If this is a question coming from your dean, you cannot say somebody has scored 80, somebody has 76, 90, 80, 79, 10. You cannot talk about all this, right? You basically will be representing the marks as aggregated marks, which is nothing but mean or average. So for your dean, the average would be a representative value of performance for this particular class of students. Let's say there are 100 students. 100 students in the class, right? So this is basically the representative value, which is nothing but mean, guys, remember. And we represent this using mu. We pronounce it as mu. Average. Average is nothing but sum by total. where this capital N represents the total values of population data that we have. Okay, this is how it is represented. But remember, when you are performing analytics, we generally want to make a generalized statements. Always, we tend to make generalized statements. Generalized statements basically means it has to be applied for the entire, right, scenario. So we always work with the data which is called as sample data. What does this mean? I'll explain. But yeah, let me finish this discussion first and then we'll come here. So let me explain the difference between mu and the sample calculation. So there is a population, friends. Let's say this is, let me erase this, redraw it, this population. Let's say this is India, the entire population of India. Okay, now on this population, let's say elections have to be conducted. Okay, in India, we have elections as you. So unless until the elections are conducted and then the election commission looks into the results, counts the results and then announce the winners, right? That's basically how it needs to be done. But even before the elections are conducted, we have something called as exit poll survey. We get exit poll survey, right? So that exit poll survey is basically to estimate, predict upfront on who is going to win the elections. So the news channels generally do this. But how do they get that exit poll survey results? They're announcing who is going to be the winner. Announcing, or they're basically presenting on who will win the elections when the elections are actually conducted. They're predicting, estimating. But if they don't have the complete data, how can you say that their result is correct? Right? You cannot directly say that whatever the news channels are saying, they are correct. But we have to consume it. Why? Because they apply a logic called as sampling techniques and inferential statistics. Sampling and then we call it as inferential statistics. So two different things. Let me explain that. The first thing, the first concept here, sampling basically means, because as a news agency, you cannot work on the complete data set. That is your population data. I mean, if you're able to do it, then we don't need election commission in the country in the first place. Isn't it? You can, as a news channel, you can do everything. You're conducting elections itself. So they cannot do that on a large scale, big scale, they cannot do it, not possible. Hence, what they do is they collect sample data and the process is called as sampling. They collect sample. But when they are collecting, there are two broad ways that you have to look at. You're not going into the details, but yeah, there are two broad techniques. One is called as probability sampling. The other one is called as non-probability sampling, friends. Okay. News agencies generally do this, non-probability. And once the sampling techniques are applied and we get the sample data, on this sample data, because I know now the data, I know the feedback of people, I'm conducting survey, right? Probably, let's say 10,000 people responded in the 130 crore population. So on this 10,000 people, when I conducted survey, I get some results. On the sample data, I get some results. Now these results, which are based on the sample data, have to be generalized for the entire population. We are generalizing it. Generalize the results to the entire nation. Right? So this process is called as inferential statistics. You're inferencing results for the entire population, right? But that is coming from sample data. That information that we are trying to estimate or talk for the population is coming from sample data. Right? So this process is called as inferential statistics, friends, and this is what we are trying to do now. Any task that you do, it's nothing but inferential statistics. Remember that. So population is what we want. Population results is what we want. We call them as population parameters. But ideally, the entire population data is not possible. Theoretically, it's not possible. Hence, we take sample data. Sample statistics. So the sample data, we do the calculations and use that results to estimate population. So when I calculate average, you will get a data. On the data, we will calculate average. That average is always considered to be your sample average, which is represented as X bar. And using this, we estimate mu. This is also average, but this is population average. So the representation is mu and X bar, remember that. Formula wise, logic wise, everything remains same. So let me give you an example here. So I have values 1, 2, 3, 4, 5. On this data set, which is sequential data, what is the average on the sequential data? What is the average? Very simple. We can also use the Excel formula. We'll not use Excel to great extension. But yeah, for these kind of small things, we use this. Sorry. We use this Excel formula. Average is nothing but 3. We can also do the calculation. Remember the average formula? Average formula is summation of xi by n, where n is signifying the size of the sample. So we are adding all of that, dividing by 5, we get 3. This is how average is calculated. Right. Now let's say there is a university, friends, okay? There is this university called as SSB. Have you heard about this university, anyone? SSB University? Okay, this is created only for discussion purposes. SSB is Sharad School of Business, okay? Just for fun. Now let's say students who want to do post graduation, they want to join the universities, business schools. One of that university is this SSB. Okay. Now let's say you all are students who have zeal to do MBA. So you are writing the entrance exam. You can say GATE exam or whatever that exam that you want to write, and you're qualified. But there are a bunch of universities from which you might choose one of the universities to join. Multiple options are given to you. Okay, so one of that university is SSB. I'm also there competing. And I would say, to attract you people, I would say that, hey, in my university, the graduates who have passed from the university have an average salary of 50 lakhs per annum. I'm marketing saying my students who have graduated from the university, they have an average salary of 50 lakhs per annum. Yeah, 50 lakhs per annum. Now, what do you think? You have other universities also to choose from. Now, when you see this ad, what is the interpretation that we have? We interpret that, hey, if I join this university and if I'm qualifying, I'm graduating, then I will land up into a salary which is giving me or which is paying me 50 lakhs per annum. Starting salary is 50 lakh per annum. Isn't that the perception that we get when we look into this ad? Yep. But do you think everybody who is joining the university, my university, SSB University, or for that matter, any university, do you think all the 100 students, assuming 100 students are there, will end up getting 50 lakh salary per annum? Do you think that would be the fact? Yep. No, right? Not everybody is getting 50 lakh per annum. It's highly unlikely, highly not possible. Right? So what exactly happens is, if I have a class of students, 100 students, if I have class of 100 students, then out of those 100 students, you will have 95% of the students like me, average students. Again, I should not be using average student. These are your regular students. But there will be 5 exceptional cases, assuming, okay, in this particular class, there are 5 exceptional students. They're exception. Now, these 5 students would be the people who are responsible to attract the global MNCs. And probably they might get an offer of 75 lakhs, 1 crore, 2 crore, so on and so forth. So 5 values are exceptional, and remaining 95% are the regular salaries. Probably 5 lakh, 10 lakh, or maximum 15 lakh salary per annum. Right? We are talking about freshers, okay? Fresh graduates. So though 95% of the students are getting these marks, which are practical, when you do the calculation of mean, you end up getting 50 lakh per annum, which is not a good sign, right? I mean, you should not have a value which is influencing by these extreme values, because not everyone is getting 50 lakhs, not possible. So 95 of the people are getting this, only 5 exceptional cases are getting high salaries. When you do average of all that, you would get a value which is like balancing between those values, extreme values as well. To explain that, let's say I'll take the same data, class A, but this time I have this. This is the data set that I have. Now, if I calculate average, what would be the average here? The measures of central tendency basically say the value which is at the center. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? This is the center. But if I draw this, this is 1, this is 2, this is 3, this is 4, and here somewhere you have 500. or 100, sorry. So this is exceptional case. Now, when you're calculating average, what would I get? 1 plus 2 plus 3 plus 4 by plus 100 by 5. So it is 110 by 5, which is 22. Now, is this 22 representing the data in any way? Yeah, majority of the data is lying here, 1 till 4. Right? And one value is 100. So you can clearly say that the value 22, which is the average, is not representing the entire data, and it is getting influenced by this extreme value. Now, this extreme value is known as outlier. This is known as outlier. And the average that we get here is 22. So when we have this kind of cases, we need to apply median. Apply median on this. Median is nothing but value which is at the center of the ordered data. So here, if you look at this, the data is having a sequential order, and we have value 3, which is at the center. So this becomes your measure now, statistical measure, which is representing the entire data. Right? Now, what if I have non-numeric data? If I have a non-numeric data, then I have to go with another calculation which is called as mode. So I have a class B, but in this class B, the data that I'm recording is not the marks, but I'm collecting on their subjects. So somebody is in computers, somebody is in mechanical, somebody is probably in civil, somebody is in, let's say, EC. Right, so this is basically the students categorization. So this is my data. I'm saying who are those students who have scored highest marks in the entire university. Right, so I'm writing the data like this. A student who belongs to computers group, he has scored the maximum marks. So now on this data, you want to again calculate the representative value, measures of central tendency. You'll not be able to do mathematical calculations on this, right? Can you do any mathematical calculation? Not possible. We cannot also arrange the data in any order to capture the center value. That's not possible. Hence, we look into the most repeated value. The value which is repeating maximum number of times. That becomes your mode. And here we have computer science. It's repeating itself thrice. Then we have civil, which is repeating twice. So the value which is most repeating becomes your measure of central tendency here. And this is called as mode. Mode. Whereas this here is known as median. Okay, so we have mean, median, and mode. That's the calculation, the first calculation that we do. First movement business decision, which is also known as measures of central tendency. Here we have mean, median, mode. All right. Next, the second moment business decision will come here. Okay. So mean, median, mode. Okay, this is basically what we have calculated. Now let us try and understand the second movement business decision. This is known as second movement. The first movement is mean, median, mode. The second movement is talking about the spread of the data. So when you calculated mean, as I said, it was talking about what is the salary probably that the people, the students who are graduating from that school are getting. Okay, so I have a data. I'm looking into the salaries, graduated salaries, and I'm trying to represent that, hey, this is the average salary. But if you actually look into the individual data, right, each person's salary will vary. It will not be constant, it will keep varying, isn't it? So to measure that variation, we have these calculations called as variance, standard deviation, and range. Now, in order to explain this, again, let me go back to that Excel sheet and try to explain. Let's take the same Excel here. All right. So let's assume I have two universities competing with each other. Okay, you are a student and you want to join the university, one of those universities. Let's say I have University A and University B. Okay. Universities are projecting assumption. Okay. Both the universities are saying that their average salary is, let's say, 15 lakhs. Okay. Both of them are saying their average salary is 15 lakhs. Now, when you try to look into this salaries, their salaries, right? Let me draw it like this. This is University A. This is University B. Okay. Now we found that the center for both these universities is same. Okay. Both of them are saying 15 lakhs. So in such case, how do you identify which university you might want to choose? Right? So let's assume again, we are assuming it, okay? So 10 lakhs is the starting salary of the graduate students. In both the universities, again, it is same. And then they have 20 lakhs as the maximum salary that the students are getting. Okay, 10 lakhs and 20 lakhs. This is the minimum salary and this is the maximum salary that the graduated students have secured. And this is the average. Okay, now let me put a different color here just to make sure that you understand that it is the center. Right. Now, let's try and evaluate this particular university's performance with respect to the salaries that the graduated students are securing here. So University A, when we look into the data, individual data, let's say here also we have few students, here we have few students. So I'm looking at each and every student's salary, how much they got, what is the offer that they received. So there is some student who received exactly 10 lakh salary. There is some student who is secured 20 lakhs here. Okay, and some students secured these kind of salaries. Okay, let's say this is the salaries. So this is 10 lakhs, this is 20 lakhs. Let's assume this is 17 lakhs. This is 15.5. This is 14. This is, let's say, 11 lakhs or 11.5, assume. This is the salaries that we have. Okay, I'm just talking about 6 values. Now, coming to University B, when we looked into the students' marks, students' salaries that they secured, they got, assume, like this. Let's say there's another probably here. So this student is securing salary of, let's say, 14 lakhs or 14.2 lakhs. This is 14 lakhs. This is exactly 15 lakhs. This is probably 15.1. This is 15.6. And this is, let's say, 16. Given these 2 data points, right? These scenarios, right? Which university would you prefer and why? Simple question. There are 2 universities, A and B. We have the we have the salaries that the graduated students from these universities secured or given. Now let me ask you people the question. I'm conducting the poll. Which university would you prefer? A or B? Yeah, answer this, friends. Which university would you prefer with this data? Still people are polling. Yeah, good. A, B. That's it, done. Nobody else has to give the answer. Now this is really tricky. 53% and 46%. So there's a really ambiguity. Okay. Wonderful. So this actually gives me a very nice platform to explain things. Okay. So if you look into the decision that you have to make, choosing A or B, and if you are saying A, then you are a risk-taking person. You are a risk-taking person because you might end up in 10 lakhs position or you might end up into 20 lakh position. A lot of variation in the salaries are there. But if you want to have more secure condition, then you would choose B. Why? Because all the students that we are looking at are consistently having the salaries around this value, around the 50 lakh value, close to the center. That means there is a consistency. Now, if you have this consistency, you can be very well be assured that you will also get similar kind of salary. But here, you will not have any guarantee. Got it, friends? Is it clear? Is it making sense here? So we will choose, practically, if you want to be very, very sure and secure, then you would choose University B, not University A. That is because you have variation. But this is only a very small amount of data. I've plotted only 6 values. What if you have 100 students details or 1000 students details? You're collecting as much as data possible for these universities, right? So when you have so much of data, then comparing these values individually like this may not be practically possible. So we need to do a mathematical calculation. We need a calculated value, right? So we are measuring what here? The consistency, the spread. We are measuring the spread of the data, right? So that spread can be represented or calculated by taking the mean as the standard value. So we are taking 15 lakhs as the standard, and we are saying that this particular student is having a variation of so much. 5 lakh variation. Student has secured a package which is 5 lakhs less than the standard. This student is again securing probably 2.5 lakh or 3.5 lakh salary less than the standard. This is 1 lakh less. This is a student who has secured 50,000 more than the standard. 2 lakhs, 5 lakhs, right? Extra. Similarly, here, if you are measuring, these are the spreads that you'll get, right? So the green lines that you're seeing is basically talking about the spread of the data with respect to the center. Now, if I have to compare A and B, I need to take all these differences and then try and compare them. Individually, I cannot compare, right? I cannot just say one-to-one mapping is not possible. It should not be done that way. So I'm going to take the summation. So here I will add x minus x bar, or let's say mu. Okay, let's not get into the discussion of mu and x bar. So let me take x minus mu. Here also, I would be marking the same thing, x minus mu. This is xi basically. Each individual value's difference is taken. And then I'll try to compare. But again, there is a problem here. Individually, you'll not be able to compare. So you're saying, let us add and then compare. But if you are just adding and comparing the values, then you will always get 0 and 0. This summation will always yield a value which is 0, friends. If you take data, any data, okay, let me take a small data set, 10, 20, 30, 40, and 50, okay? This is your data set. And on this data set, we are saying x minus mu. In order to calculate, first we have to measure the mu here. What is the average? It is 30. Average is 30. You can do the calculation. So now I'm doing average x minus mu. So 10 minus 30 minus 20. 20 minus 30 minus 10. 30 minus 30 is 0. 40 minus 30, 10. 50 minus 30, 20. So if you add all these, what you'll get? Summation of all these values will always be equals to 0. You experiment by taking any random data here in X, measure the average, and then do the difference, add them, you'll always end up getting 0 only. Right? Because some of values from the center would be below the center, few of them will be above the center. Remember, mean is the value which is balancing the data points, right? So obviously, if you add the values, it will give you result 0. Then how can I quantify the values? I need to quantify and understand which is more consistent here, right? So in order to take the magnitude, we square the value so that the negative symbol is removed. This way, I will not get 0. So I'll be able to compare. But again, there is a problem. What if University A has, let's say, only 100 students, whereas University B has 500 students data? So here I have 100 students data, here I have 500 students data. So you're doing the difference of 100 values from the center, whereas here you'll be doing 500 differences and summation. So this value might always be larger because you have more number of data points in this case. So you'll always get this as the data which is having high variance, high variability. That is not the fact, right? So we need to actually take a value which is representing the entire spread for all the data points here also. And that representative value is nothing but average. And what is the formula of average? Sum by total. And what is the value that we are trying to measure here? Representative value is for squared differences. So you take these square differences and divide by total number of values. Now this is basically talking about the representative value for entire data set of A, and this value is representing the spread of the data for B. Now this value that you are getting will be used for comparison, and we call this as variance calculation. But there is a problem again, right? Variance we calculated very good, but there's a problem. Mathematically it can be calculated, but logically you'll not be able to interpret it, because if you talk about this, we are talking about salaries, right? We're talking about salaries of the students. So when you're calculating average would also be salary, and you're differencing x minus mu, this would also be salary. But the challenge is when you're squaring that. Here you're squaring it, right? So you're going to get salary square. That means INR square or dollar square. So your units that you're talking about, which could be INR here, right? The units are getting squared. If units are squared, how can you interpret that data? Not possible, right? There's no meaning to it. Unit square, what does that rupee square means? So mathematically, variance is very well used. We can calculate that. But for interpretation, for explaining, we need to bring that units back. And in order to bring that units back, because it is squared, we apply square root. We apply square root. And this square root is standard deviation. We call it as standard deviation. Remember, we are calculating the deviation from the center, but we are representing all the data's deviation using a single value. So it becomes a standard for the entire data now. Hence, it's called as standard deviation. Right? Variance, standard deviation. All right? Square root of variance is nothing but your standard deviation. So this is the measure of dispersion, measures of spread. Now, using this value, you will be able to choose either A or B, University A or University B. Okay. Now, one more thing that you need to look at here is the spread of the data. See, you're calculating variance, standard deviation and all that, very good. But you also have to see that the spread in the data could vary. In our discussion here, as just an example, we've considered that the maximum and minimum will be same, but it may not be same all the while. It might be different for different data sets. Given that spread, which is like the boundary, which basically talks about what is minimum and what is maximum. Given this boundary, we should be able to measure the spread within this boundary. And this boundary is basically representing the range or the spread of the data, the range of the data. Right? So let me give you a very nice example. Why range is required. Right. So there are two friends, let's say, yeah, couple, lovers. They went out hanging, and this guy has, right, spent everything, all the money that he has, and the lady, she did not bring any money. Generally, they don't get, right? Yeah. Guys, you know. So just for fun. So let's say there is a scenario. These people have went out, and there is no money now. They have to return back. But while returning back, they observed that they had crossed this river body. There's a water body that has to be crossed. And there is this boat, right? And if you have to cross the river, this is the only way. Okay. And there is a board saying that, hey, beware that there is this water body. And on the notice board, you can see that it says 4 feet depth average. So it says that, okay, let me rewrite it. Probably I'll write it in a big font so that it will be easy for you to read with respect to, let's say there is a board here, okay? That board is saying average depth of this river body is 4 feet. Right. Now this guy is not allowing people to get on, hop on, because he need money. But these people, they don't have any money. Now, yeah, this guy is little daring and sees that, hey, there is only 4 feet depth, right? So let's cross. That's okay. We can cross. He's asking, hey, do we have any dangerous things in the water? Now he says, no, this is a regular water body. No crocodiles, no snakes, nothing. You can, yeah, very well swim in it. So this guy gets into the water and he tries to cross. Should he cross or not? That's the question. Right? So what is happening here is, this guy probably is 6 feet tall, okay? He's very tall, 6 feet. And he sees this board which says average depth is 4 feet. So this guy says that, hey, I'm taller, right, than the depth that we have in the water body. Let me cross it over and get some money back, and probably I'll take you back. So he's getting into the water. But the problem here is, he doesn't know what is the maximum depth. Average depth is 4 feet. Very good. Here it could be 1 feet, 2 feet, 3 feet. But there might be here somewhere, it could be 20 feet depth. So this is the maximum depth. Unless until you know this maximum depth, you cannot get into the water. Right? So it's not just the average depth that you will need to look at, but you need to look at the maximum and minimum also. So spread of the data does not only mean the average spread, variance or standard deviation, but you also have to look into the range, minimum and maximum depth of that particular water body for in this example. All right. Now variance and standard deviation, they are represented as sigma square and sigma. And for sample, s square and small s. Okay. And we have a concept called as degrees of freedom also. This is used for getting the best estimate of population parameter when you're using sample statistic. So degrees of freedom is required when you are using sample standard deviation calibration. So the denominator is not small n, but it is n-1. So one value will be constant. Out of n values, we will have one value which is going to be a constant, so that when you are estimating this, we will get as close as possible to the estimated value. This is your required when you are doing predictions. So this is basically your measures of dispersion. And you'll also have third moment, fourth moment, right? Those cases will also be there. So this is about your first moment and second moment discussions. Now, before I proceed, I want to talk about very important point, which is called as probability distribution. We all know what is probability? Yeah, friends, we all know probability, right? Now, okay, let me look into the probability question. Okay, let me ask you a question. Let's see. Who knows probability better? Yeah, so probability formula is the number of desired events, or I would say interested events, by the total values, total number of events. For example, if I'm rolling a die, the possible outcomes are 1, 2, 3, 4, 5, and 6. And if I have to measure the probability of me getting a die, which is, output, which is 1, then the probability is 1 by 6, right? Probability of 2 is also 1 by 6. 3 is also 1 by 6, 4 is also 1 by 6, 5 and 6. Right? So we have probabilities for each and every value in this experiment. Now let's see how many of you actually will be able to answer this question. Listen carefully, the question. Let's say there is a jar with chocolates, 10 chocolates. Okay, and in this, let's say I have 5-star chocolates, 5 stars are there, and I have 5 stars, and I have 5 Cadbury. Okay, so total 10 chocolates, I have 5 stars and 5 Cadburys, 10 chocolates. Now, on this, in this jar, you are trying to pull out one chocolate. Okay, let's say picking one chocolate. Pick A. I'll call this as pick A, first pick. What is the chance that you end up getting a Cadbury? So the answer here would be 5 out of 10. So if you're choosing any one of these 5 Cadburys out of 10 chocolates, then your condition is satisfied. So it is 5 by 10. Now you liked it very much, you ate it. Second pick, you're picking another chocolate now. Pick B. Now tell me, what is the chance that you again get a Cadbury chocolate? Okay, so this is the question. Let me take a poll now. Okay. What is the probability of the second pick? It's 4 by 10, 4 by 9, 5 by 9, and I'll have 5 by 10. All right, let's see who gives me the right answer. What is the probability of the second pick so that we get Cadbury's again the second time? Okay. Yeah. Cast your vote. Cast your vote. I don't see. Everyone is doing that. Let's see what everyone has to say. Oh, okay. I have 5 by 10 as well. 5% of people are saying 5 by 10. Very good. But I expected some other result. Okay. 8%, 73%, 13%, and 4%. Okay. Okay. So let's answer that. Okay. Let's look into the answer of that. What does our event 1 say? The probability of picking the Cadbury chocolate is 5 by 10. Right? But tell me, does this probability 5 by 10 will always say that you will get Cadbury chocolate in the first pick? No, right? It's only a chance that we are calculating. Now, if you would have got the Cadbury's chocolate in the first pick, then you would have only 9 chocolates left out. So denominator becomes 9, and you have already consumed that Cadbury chocolate. So you'll have only 4 by 9 for the second pick. But if your first pick, if it would have been a 5-star chocolate, because 5-star chocolate also has equal chance, 5 by 10. So when you're randomly picking, you might get that also. In such cases, you would have consumed 5-star chocolate, not Cadbury's. So denominator would be 9 because you have anyways consumed 1 chocolate. But your 5 Cadbury's chocolate would have been intact in such cases. Yep. So you either have this chance or this chance for event B for picking the second chocolate. 4 by 9 or 5 by 9, you have equal chance. Remember that. Now, this probability discussion that we are having is called as conditional probability. We call it as conditional probability, where event B's output is purely depending on event A, the outcome of event A. So B is dependent on A. So the events, I'm writing here, events A and B are called as dependent events. When we have dependent events, we do conditional probability. Remember this. Very, very important concepts, very foundational, very, very basic, but very much required. Okay. So we also have something called as Bayes theorem. If you remember school days, we were discussing about this Bayes theorem, Bayesian theorem. Right? It is based on this. So probably you might want to refresh, right, the neurons in our brain, right? Trigger them again. Read about this. Right. Now I'll ask you a simple question now. The probability cases are done. Now let's say I'm flipping a coin, friends. flipping a coin. Okay. On this event, in this experiment that you are doing, what is the expectation? I want to guess what could be my output. Can you guess? I'm giving you a coin. I'm asking you to flip the coin, and I'm going to ask you, hey, what is the output that you're going to get? The possible outcomes for this experiment are either heads or tails, isn't it? Two options are there. Now, if you want to upfront guess on what would be the output that you might encounter, then you will have to see what is the chance head has and what is the chance tail has. And the prediction is all about looking into these probabilities and trying to capture the value which is having the highest probability. In this case, it is having equal probability. So you might not say that I would get head or I would get tail. But in reality, in practical cases, you would have different probabilities. You'll not have always uniformly distributed probabilities. So one such example here. Assume you are the owner of an Apple iPad store and you're making a sale of iPads. And the management, right? I mean, your team, you're the owner of the company. You and your team are calculating the chances of sales. These are the number of units of sales that you're making on a given day. And you're saying that 0 sales, 40%, 1, 25%, 2 iPads, 20%, 3 iPads, 5%, 4 iPads can be sold with a chance of 10% on a given day. That means you have a 10% chance that you end up getting, you end up making 4 iPads on that day. Right? So given this data, of course, we can represent the data in a graphical representation like this. Here you're talking about this X, and here you're talking about the probability. Now, I want to try and understand how the probabilities are distributed among the possible set of outcomes. By looking at this, can you tell me what is the chance of a sale? What is the probability of a sale on a given day, given this data? Okay, calculated, everyone? We are looking at the probability, the chance of making a sale on a given day. Sale means you either sell 1 iPad or 2 iPads or 3 iPads or 4 iPads from your set. If you end up getting 0 sales, that means no sales on that day, right? So in order to capture this information, you'll simply look into the probability summation. You add all these probabilities. That gives you the sale, probability sale, which is 0.6. That means you have a 60% chance that you make some or the other sale on that particular day. You can also say that 40% chance no sale. That means, of course, 60% chance you'll have sale. Right? So if you look into the individual days, this is how it looks like. One day you might sell no iPads, nil. The other day you might make 4 iPads sale. The other day you might make 2 iPads sale, 3 iPads, 1 iPad, 0, 0, 0, 2. Each individual day you might have different number, but we are looking at the probabilities, the chances for a given day. Now, using this probability, we will be able to identify the business scenarios, the standards. Now, calculate the second one. What is the probability of selling at least 3 iPads? At least 3 iPads basically means You either sell 3 or 4 or more, at least 3. So we will say probability of random variable having at least 3 or greater than 3. So we will add these two and we will get 15% chance that we have 15% chance that we make at least 3 iPads sale, right? This kind of information is available from the mathematical calculations of probability. So probabilities, right, or the statistical calculations that we have learned today are used for making business decisions, right? We use these calculations for interpreting the business conditions and taking some informed decisions. Right. So this is about probability distribution. In the next class, we'll stop today here. In the next class, we will look into the machine learning algorithms, the paradigm of machine learning algorithms. Okay, that would be tomorrow. We'll start with machine learning. All right, hope you have attendance link shared. I request everyone to share your attendance. Okay, you already have the attendance link here on the sticky note on the chat window. Very good, yeah. All right, so people who have not subscribed to YouTube channel, I would again request you to subscribe to the YouTube channel. Not sure if you have got the insight on central limit theorem. Yesterday we had a session on central limit theorem, which is one of those important concepts in the stats. If you have not subscribed, do subscribe onto that channel so that you get all these live sessions. Okay, so do attend. Very important. And yeah, this is our website, and you might want to explore the programs as well. We also have chatbot. Not sure if you have explored the chatbot. You might want to talk to chatbot as well. It'll be fun. Just try and explore this, guys. And you can also connect with us to understand the webinars that we are doing. We have social media channels. Yeah, this is our entire website. You have Facebook, Twitter, YouTube, right? So you might want to connect to our LinkedIn as well. Just take the advantage, guys. We do a lot of free programs, so you might want to just connect and take the advantage. Yeah. So this is our LinkedIn page. Please do connect, okay? All right, let me take your questions if you have any now. How to put attendance? So you have the sticky note, right? There's a form given. Dr. Swagata Bira. Did you get the link? I think it's already pinged. Yeah, let me just put a message again. You just have to enter details in that particular link. All right, any questions, friends? Do we have any questions? Jyotsna, it's not which mathematical concepts. That's probably a wrong question. Entire mathematics is important, but you can start with linear algebra. You can start with 8th, 9th, 10th standard mathematics. Begin from that. We cannot cover everything, Mukhtar, in the time frame, short time frame. There are so many things that we'll have to do. So I cannot explain everything. Probably you can connect with the YouTube channel and take the advantage of that. There are a lot of statistical related videos that we have. Go through that. I request you to go through that. Transformation is basically to make sure that we have the data following a specific pattern. If the data doesn't follow a specific pattern, then we apply transformation techniques. Hey, thank you all. Thank you. Thank you, Nigama. Thank you, Jyotsna. Thank you, Yogita. Thank you. Mukhtar, I'm again informing you, will not be able to discuss everything in the short duration, Mukhtar. That's not possible. If I have to explain transformation, again, I'll have to spend at least half an hour. I would request you to go through the videos, YouTube channel, right? There are a lot of videos which talk about it, 1 hour videos, 2 hours videos. So go through those statistical related videos, right? So it will help you. Hey, thank you, Dr. Swagata. All right, any more questions, anyone? Do we have any questions, friends? Not really, Mukhtar. That's not the transformation meaning. That's not transformation, Mukhtar. Hey, thank you, Moin. All right, friends, if no further questions on the topics, we can wrap up. Python, Swagata. So we will be installing Anaconda software. Anaconda. And in the Anaconda distribution, I will be using Spider. You're free to use any of the distributions that Anaconda is giving. Underneath Anaconda, you will have Python engine, which basically is doing the entire executions. So probably tomorrow we'll start with that. Hey, all right. Thank you, Dr. Asha. Thank you, Swapna. Thank you, Arundhati. Okay, it's just a Anaconda website. You can say anaconda.com. It's anaconda.com. And then you see products, individual edition. And you can say click download. It will redirect you to the download page. At the bottom, you have this download option. Based on your OS, you have to choose that relevant version to download. And go with the default installations. Yeah, I've pinged the link. Just click on this, come to the bottom of the page. You have the Windows, Mac, or Linux options. If you are using a 32-bit Windows, you can choose this. If you're using 64-bit, use this. But go with Python 3.7 version. Don't go with Python 2.7. That's a older version of Python, which is now not supported by Python community. So go with Python 3.7. All right, yeah, sure. All right, friends, so let's wrap up the session for the day, and let's connect again tomorrow. Thank you so much, and stay safe.